Hi. Separation of gases from air using fractional distillation method. First, let us check the process. The air collected from atmosphere is compressed and cooled by increasing its pressure and decreasing temperature. Then that compressed and cooled air become liquid air. Then the liquid air is allowed to pass through the fractional distillation column where the liquid air is allowed to warm up or heat it up slowly. When the liquid air is heating, according to their boiling points, gases are separated at different levels, right? So one point you have to remember here, whereas in distillation or fractionation distillation, what will happen? Air is compressed and cooled, then it is become liquid, then it is boiled, when it is then it is become vapor. What is the key point you have to observe here is when the pressure is increased. This is the cylinder filled with gas molecules at high volume at low pressure. When you increase this pressure by applying the external pressure like this, what will happen? The volume will be less. That means the gas molecule will come closer. When come closer, the intermolecular forces between gas molecules become stronger, and they in a such way that they can attract each other and becomes liquid. Okay. This is the schematic diagram for the separation of components of air. Let us check this. The collected air from the atmosphere is allowed to go through this chamber where the external pressure is applied using these pistons. Now the air is under compression. What will happen? The heat will also increase. Why? It's just like if you have 10 members in your classroom sitting there, you feel very comfort and airy, right? In that classroom, if you have 100 members, how do you feel? Become warm and heat, right? In that sense, the compressed air become hot, but you need to cool it down to make it liquid, right? Then this hot air is passed through this condenser where the freezing cold water is circulated like this to make the hot air into cool air. Now the air is cool and compressed. This cool and compressed air is allowed to go through the separator. Initially, the carbon dioxide out as a dry ice. You know what is dry ice? Why? Why it happened? Because when air is cooled at a very low temperature during the process, CO2 reaches its sublimation point. What is sublimation? Vapor directly becomes into solid, right? And it solidifies. CO2 vapor solidifies when the temperature cooling down to minus 78 degree 0.5 degree centigrade. Okay, this is how happened here. Then the remaining liquid will go through this expansion jet into fractionating column. Here it is the main thing we need to focus, right? Here in this fractionating distillation column, what has happened? The mixture, the liquid is allowed to warm or heated. Then what will happen? The nitrogen, argon and different gases are evaporated according to their boiling points and collected at different levels, different heights, it is saying. The liquid, the whatever the gases form in liquid, they'll collect it from the bottom of the fractionated column. This is how the components of air separated. Okay, we have learned this, but where do you see in domestic life? Okay, check this one. Even though every gas has a tremendous applications in both domestic and industrial applications, but I just picked up few picks to make you understand easily. The chips packet, you'll see the nitrogen gas cylinders, helium cylinders and oxygen cylinders all over, right? So what are their applications? What they can do with the separated gases? Here the simple application is just chips packets. The chips packets are filled with nitrogen gas. Why nitrogen? Because the nitrogen gas doesn't react with this fats or salts or anything in the food. That's why these kind of packets are filled with nitrogen. Then helium gas, to inflate the balloons, so this is the one application. Oxygen cylinders, how important it is in today's world, right? These are the familiar applications you can connect with. That's why I picked up these pictures. Okay, see, this is the manufacturer photos or pictures I have collected for you to show you how big the fractionating columns are to separate the gases from air. And see, this much big they are. This is one plant manufacturing the gases, and this is another plant from China, I think. These are pictures of fractionating columns in industries manufacturing the gas cylinders, right? Now, increasing order of boiling points of gases in A. So, which gas comes first? Which gas evaporates first? Or you can say, which has the boiling point? Nitrogen gas, minus 196 degrees centigrade. Another gas, argon, which is at evaporated minus 186 degrees centigrade. Oxygen vaporizes at minus 183 degrees centigrade. Finally, carbon dioxide. It will not vaporizes, but it come into dries, right? Which gas forms the liquid first as the air is cooled? Okay, the oxygen forms liquid first as the air is cooled. Why? See, oxygen when compared to argon, nitrogen, neon, oxygen, helium and krypton, I just make it available list here. The oxygen has this much of boiling point, minus 183 degrees centigrade. I'm not mentioning krypton, it is very less abundant. That's why oxygen forms liquid first as the air is cooled. Okay, so from the 0, like 1 2 3 minus 83 will come first, right? So that's why the oxygen form liquid over there, then going to the next one, like that, because oxygen has highest boiling point compared to remaining gases in the air. Just what I explained here. Okay.